Okay, so here I'm going to discuss solutions to the problems in quiz 2. So I begin with very first problem, which gives me a vector v and a vector w, and I'm interested in finding what is v plus w and what is 2v minus 3w. These are really simple problems. So v plus w is nothing but we just add the corresponding components, so I'm not just putting so many details here. This is 2i and this is minus I, so it should be I only. I'm using I hat because in this notation they are using this bold I, so I'm just using I hat instead of bold I. And the second one is negative j plus 4j, which becomes 3j hat. And the last one is 3k plus 0k, which is 3 plus 0 is 3k. Okay. Similarly, 2v minus 3w should be 2 times vector v minus 3 times vector w. Now vector v is 2i minus j plus 3k and w is minus I plus 4j plus 0k. So if I distribute 2 inside, this becomes 4i minus 2j plus 6k, and this one is plus 3i minus 12j and again minus 0k. Now if I add corresponding components, 4i plus 3i will be 7i, and negative 2j and negative 12j would be negative 14j, and the last one is 6k minus 0k should be 6k. So I'm mostly talking about what the method is, so if there is any typo, if there is any like arithmetic mistake, please take care of that thing by yourself. So here I'm going to talk about what is the dot product of v and w, and we know that by definition this is v1 w1 plus v2 w2 plus v3 w3. And if we look at these vectors, like the x component is 1, which is v1, and this guy is v2 and this negative 2 is v3. Similarly in w, this is w1 and this negative 1 is w2 and this guy is w3. So if I use this definition now, I'm using v1 times w1, which is 1 times 3 plus 2 times negative 1 plus minus 2 times 4, which is 3 minus 2 minus 8. So this is negative 7. Okay. Now I have to find whether the angle between these two vectors is acute, obtuse, or right. So for that, first I need what is the magnitude of vector v, and the magnitude of vector v is square root of v1 square plus v2 square plus v3 square, which is 1 square plus 2 square plus minus 2 square. So I'm just using this v here, so just v1 v2 v3 I'm using here. So this will give me square root of 9, you can check, which is 3. And w, the magnitude of w is square root of 3 square plus minus 1 square plus 4 square, which is root 26. So from this geometric definition now, The left hand side is the dot product, which is equal to negative 7, as we know. So left hand side is dot product, which is negative 7. Right hand side is magnitude of both, which is 3 roots 26 cosine theta. From here, cosine theta is negative 7 over 3 root 26. So you can see that this cosine theta value is negative less than 0, then the angle should be obtuse, because we know that cosine has positive value in first quadrant and negative value in second quadrant. This is 0, this is 180 degrees, which is equal to pi radian. So if the cosine value is positive, we are in the first quadrant. If it is negative, we are in the second quadrant. So if the angle is in second quadrant, sorry, it's not working. Okay, yeah. Second quadrant, then obviously the angle should be greater than 90, so the angle is obtuse. Okay, very simple problem. Now the third problem is, I have to just check that these two are perpendicular, and this simply means that you take their dot product should be equal to 0. If they are perpendicular, I have to find the value of m. So the dot product is, like we know the definition, like v1 times w1, which is 1 times 2, and v2 times w2, the coefficients of j, which is m times 1, and then negative 2 times 0 is equal to 0. So this is 2, this is m is equal to 0. If you subtract 2, the value of m is negative 2. Okay, very simple. Now we have to find the equation of the plane with this normal vector, and you know normal vector is a vector with the name that we are using is this, like a units in x direction, b units in y direction, c units in z direction, and this is the point that lies on the plane, which is x0, y0, and z0. Now this is the equation of the plane when we know this normal vector and we know a point on the plane, so we are just going to substitute the values. So this is a is 2, x minus 1, b is negative 1, y minus 0, because that's y0, c is 3, z minus minus 2 should be plus 2 equals 0. So this is just the equation in point normal form. Now if you want to simplify everything, like we are going to simplify this thing, which is 2x minus 2 minus y plus 3z plus 6 is equal to 0. So 6 minus 2 is 4, and if I subtract 4 on either sides, the answer is equal to negative 4. Okay, so this was question number 4. Question number 5 is really simple. So what am I doing? I'm just proving this this formula, the formula for the dot product. So what am I doing? I'm taking two vectors. This one is vector v, this one is vector w. Obviously this vector should be v minus w. So now the thing is that if I'm taking this angle theta between these two, then law of cosine says that okay, the magnitude of this v minus w squared, like this one squared, is the magnitude of this one square plus this one square minus 2, the magnitude of both multiplied by cosine theta. This is like simply, if I have a triangle, sides ABC, angle theta, then c square is a square plus b square minus 2ab cosine theta. Okay, So I'm just doing the same thing now. What am I doing? I'm just evaluating the left hand side. Left hand side is like, since v minus w is a vector whose components are v1 minus w1, v2 minus w2, and v3 minus w3, I'm taking its magnitude and squaring it to get this thing. Now this thing is really simple to understand. I can show you. First of all, what is v minus w? V minus w is v1 minus w1 in the ith component, v2 minus w2 in the jth component, and v3 minus w3 kth component. So what is its magnitude? Obviously that thing should be v1 minus w1 squared, like you square each component, v2 minus w2 squared plus v3 minus w3 squared, and you take the square root. Now if you add a square on both sides, the square cancels a square root, so we get rid of these things. So this is what we get, which is magnitude of v minus w squared, as you can see here. Now I expand the first term, the second term, the third term. Obviously this should be a negative sign. This is positive, negative, positive, negative, positive. Now if I combine these square terms, I get this. If I combine other terms, I have a negative sign in front of these all, and this negative sign comes from these three negative signs. Then what I can do is I can substitute the value of magnitude of v square and w square on the right hand side. Obviously these two quantities are equal to this quantity and this quantity, so this one cancels. Now left hand side only becomes this guy, which you can see here, and right hand side only becomes this guy, which you can see here. So this is the equality that comes after simplifying from this equality. Now if I divide by -2, then I get this thing, which is the definition of the dot product. So this shows that, okay, the geometric definition and algebraic definition are equivalent to each other. So there are two ways to define dot product. One way is like you do it algebraically, and another way is like you do it geometrically, like this, w cosine theta. So this was quiz 2. I think it was pretty simple.